Welcome to the end of lesson exercise, how to calculate for positive predictive value and negative predictive value, and again, using the 2x2 table. By now, you should be familiar with this table. What I had done in this exercise is to give you a table that's incomplete. I'd like you to complete it. You can tell here the disease, those with colon cancer, those without colon cancer, those that are positive on the instrument, a test called Hemoccult, and here's your exercise. A colon cancer screening test is being conducted in England between 50 to 70-year-olds using the Hemoccult test. So if the prevalence is 12 for every 1,000 people, and I've given you here those that turn positive using the instrument, the test called Hemoccult, and they truly have colon cancer, according to, let's say, a prevalence of 12 for every 1,000 people in the population. To get the false negative, you just merely deduct those that are true positive from the total positive colon cancer. And the negative on the Hemoccult and the people do not have colon cancer is this figure. You merely deduct that from the total of all negatives, and that would be your false positive. The total for this row is just merely adding your true positive with your false positive, and the total for the Hemoccult negative is adding your false negative to your true negative. We need that to be able to calculate for the positive predictive value, because that total of true positive over all the positive true and false positive will give you the percent positive predictive value for a test. To calculate for the negative predictive value is merely dividing the total negative, which is this one, over all the negatives for that row, including the false negative. To answer this, if the prevalence of colon cancer is 12 out of 1,000, is this low, high, just right, or none of the above? In order to answer that, what do we call a rare disease? Most definition of rare disease is less than 10% of all diseases. So if you divide 12 by 1,000, would that be less than 10%? And that would be your guide. If it is, then it is a low prevalence disease. And then if it is a low prevalence disease, what is the best way to predict a low prevalence disease? Is it to have a low positive predictive value instrument, a high one, or a low negative predictive value or high negative predictive value? And you can find that on slide 14 of module C 5.3, and that should be very easy for you to answer. All right, that would be the end of lesson on calculating positive and negative predictive value.